Hello everyone. Let me introduce myself. I am Meher Baba. I am studying in BTech second year in School of Computer Science Engineering at VIT Chennai. Today I am going to discuss about Project 1 in Nand2Tetris course. The basic aim of the Nand2Tetris course is to build a general purpose computer using basic logic gates from ground level. So without any delay, let's get into our project.
Yeah, this is our project regarding Nand2Tetris. Now let's go to introduction. Why we are using Nand2Tetris and what is Nand2Tetris? Nand2Tetris is an unique and exciting project or course that gives us bottom-up approach to computer science education. By using this, we not only build digital circuits, NAND gates, etc. We can also understand how a computer works from ground level. Why we are using this Nand2Tetris? Yeah, well, Nand2Tetris provides us an easy way to build fully function computer system using very basics of computing. And this Nand2Tetris provides how a computer works from low-level hardware to high-level software. This course not only teaches the technical skills and all, it also provides us the problem-solving skills and critical thinking and essentials for any computer scientist. Software tools. It generally has six software tools. First one is HDL. It is a programming language that describes digital circuits, and here we will use hardware description language. Next, hardware simulator. This project provides us a custom hardware simulator called hardware simulator, and it tests and debug our HDL code by simulating it. And next, assembler. An assembler is generally a program which converts the assembly language into machine language. And next, VM translator. VM translator is reverse to it. VM translator is a software tool which converts the virtual machine language into assembly language. Next, compiler. Compiler. The project provides a compiler that can be used to compile high-level language like Jack into virtual machine language. Operating system. It is a well-known item. It is a well-known system. It is a collection of programs that run in our system. It acts as an interface between user and computer. Next, Boolean logic and functions. Boolean logic is a type of algebra that deals with binary values, and it has only two values, true, false, or 1 or 0. Basic operators of Boolean functions or Boolean logic are AND, OR, and NOT, etc. AND is generally returns true when both the inputs are true, or or returns true when at least one of its input is true. Not is basically negation of the input. NAND, which is the title of our course. NAND is a combination of NOT and AND gate. It is a logic operator which returns true when both the operators are false. Next, the objectives of the project 1. Build the following logic gates like NAND, NOT, OR, etc. by using the code which they have already provided in the tools box. Here we generally see two types of simulations in our PPT, and its first one is interactive simulation and second one is script based simulation. And first one is the interactive simulation. Here we will see input, output and HDL code. And in script based simulation we will see the truth table by running all lines in script so that we can get the truth table. Let us simulate in interactive and script based manner. First select hardware simulator from Nand2Tetris file. In tools it will be there, and select a chip from here, like we can choose any one of the gate from project 1 and 16 demux like that. Let us suppose load end, and here we are getting output 0 for both A and B taking as 0, and we can change input. Well, let's keep it for 1, enter and run it. As we are giving input 1 and 0, we are getting output 0. And now let us see script based simulation. For script based simulation, we can click here load script, and choose end text, and we are getting here the script regarding that end gate. And by using this symbol we can run single line by line and step by step. Okay, first step it go by running these 4 lines, and first case it is A is 0 and B is 0, and we can get the output as 0, and it will run by running these 4 lines, and it will go to next step, then next step. Here inputs are 1 and 0, and we can get the output as 0 absolutely, as any one of the input is 0 and it will be output will be 0 for AND gate. Next, if next step, by taking both inputs 1 like true, we will get definitely output as true. So next run it, and now we can check the output. It is a truth table of AND gate. And now let's check for another example by taking mux load chip, and these are the inputs and respective outputs, and this is our HDL code. These are internal pins, and we can change it to 1, enter, run. We can get output pins A equal to 1 and B equal to 0, and now let's keep select also 1, run. We are getting A as 0, B as 1. Now let us see load script demux, and this is the script of demux. Now let's run step by step. Step 1, step 2, step 3, step 4, and now we can see the output by clicking in view script to output, and we can get the truth table here. Now again verify for another example. Now let us take mux load chip mux and change the inputs A as 1, B as 1, and now run the code, and we are getting output as 1. Now let's see script based simulation. Load the script, and here is the script, and run step by step by clicking in single step. These are all the cases of mux, and when we keep it to output in viewpoint, when we change script to output, we can get the truth table for all the cases which we have seen in script. And now let's check for another example. Let's take it as mux 8way16. Load the chip and change the values as your wish. 1, enter, 1, enter. Now let's run the code by clicking on this calculator. We can get the output 1. And now let's check for script based simulation. Load the chip mux 8way16. This is the script regarding it. Here A16 means each input is taken in 16 bytes. So we can get the output also in 16 bytes. And now let's run step by step by clicking on this single step option. First step, second step. These are all the cases or column or rows in truth table. By clicking on, in every click it will run each case and views our output finally. See, as the output values are changing here and input values are also changing. So finally our code and our cases ends here. Now let's check for output. See, these are all 16 bits, as our input is in 16 bits, and we can get the output also in 16 bits. Now if we move like this, we can get. Now let's check for another example. Now let's check for an easy XOR gate. Load the chip XOR gate, and here we go. These are the internal pins, outer pin, output pins, input pins, and this is our HDL code. Now let's change the inputs. 1 0. As we know, if both inputs are different in XOR gate, then we can get output as 1. Let's check for it. Yes, we get the output as 1. Now let's go for script based simulation. Load the XOR script and run each script, each case 1, case 2, case 3, case 4, and now change here script to output so that we can get the truth table of XOR gate. Now let's end the session of the simulation. Now let's go. Now let us see the output screenshots for interactive simulation and script based simulation for all 15 examples, in which we have seen a simulation for 5 examples. This is the output screenshot for NOT gate. This is the output screenshots for NOT 16 gate. NOT 16 means we have already discussed in simulation that input is taken in 16 bytes. And this is output screenshot for AND gate, interactive based simulation and script based simulation, both screenshots. And 16 gate, OR gate, OR 16 gate, XOR gate, MUX, DMUX, MUX 16, which input is taken in 16 bytes, or 8-way, input is taken in 8 bytes, DMUX 4-way, DMUX 8-way, MUX 4-way 16, MUX 8-way 16. By the end of the project, I am going to conclude my complete understandings on Boolean algebra and logical gates such as AND, NOT, OR, etc. And I have learned hardware descriptive language, how to build a code for a given gate or logical circuit. And third thing, how to debug or test the code using hardware simulator. And next thing, we can build any circuit by using NAND gates, and it is the foremost important point. I want to conclude this. And finally, thank you all for watching my video.